We are now in the farm guest house. This is the soil moisture station assembly station, and most of this is put together. We started with this metalwork which was welded up. We have attached the ground wire for the surge protector to this one nut here. We've tie wrapped the wires up the length of the pole. We're about to connect the solar panel to the charge converter, and this has 4 screws. You lift the lid off, and there's a rubber gasket, and then there's 2 sets of terminals here that I'm going to be soldering the wires to. We've had a few things we've had to work around, like I thought we were getting 1¼ pipe and we got 1¾ pipe, so I had pre-drilled some holes in this mounting backplane, which then had to be enlarged and moved over. So it's great to have a backplane in this cabinet, because that way if you do have those kinds of mistakes, you can deal with them pretty easily. So we just bolt these units down with small screws. The battery I chose to tie wrap up off the base of the unit so that I could get these bolts down here and center it on the pole. The charge converter is mounted up here. 2 screws, and then it's wired in both to the battery as well. I've wired it into the connections here, which connect to the batteries over there, and then the other 2 wires go down to the solar panel. We've got some terminal blocks here for easy connections on these. These are engineering model units. These are not the connections that we'll be using in production, and we again have compression seals for the exit of the wire from the boxes. And these are pretty tightly sealed boxes, but they're not submersible boxes. This is a pretty stout stand using 1¾ galvanized pipe. I believe that that's necessary because when you weld these tabs on, if you use a lighter gauge like 1¼ pipe, I don't think the wall thickness is great enough to make for a sturdy weld. So yes, we have a sturdy weld, and we have a very heavy assembly using that larger pipe. So we've got pipe clamps that go around, and this was one that just because we didn't have the other size, we made do with this one. We've got the RF cable to the right coming out of the box, looping up to the antenna, which is on this side. And then we have wires coming out also out of the bottom. There is a power wire that runs to the solar panel. There are 2 moisture sensor wires that run down the length of this pole. And then here is the actual moisture sensor probes with their protection caps on them that will bury. And then we've got a ground wire which we connect, and that ground wire connects to the surge protector, which is this device, Elcom device down here. So if there's a lightning strike nearby, this will short that energy received by the antenna to the ground. It will not protect it from a direct hit, nothing will, but it will protect it if lightning strikes in a nearby area. Fed the wires through, and there's a compression cap right here. You want to make sure you put that on first, and then this screws on, and I'll tighten this here in a little bit. So the wires are through. As you tighten that cap on, it will squeeze the wire and provide a moisture barrier. So the panel has a marking plus and minus. In this case, the yellow is plus and the blue is minus. So I'm going to bring those down to these tabs and squish them together, and then I'm going to solder them up so it's a very solid connection. Just now I've applied some silicone to the bottom holes of this box. It is not my intention to seal it up watertight, because if water does get in, we want it to escape. So I've gone about 3/4 of the way around each wire bundle. We want to make sure that the bugs and other insects don't get up inside and start to nest. So there's enough gap for water to exit the box, but not so much so as to provide a nice nesting opportunity for bugs. I've also put some a little bit around this cable, as it's not a round symmetrical cable, just as a precautionary measure, so that gasket can have some added sealing. And then finally, there was an extra hole because the clamp was too small, so I squirted some RTV down where that extra hole was. It is backed by a plate, but thus shouldn't be too leaky, but still it is a pretty big hole, and so I've RTV'd over that plate and over the plastic to seal it. The final assembly of this station, I've got a little checklist here of things I learned as I've built these up. We've got a total of 8 that we've built, and so this is the last one. I'm going to run down the checklist of things that I need to make sure, which for example, make sure it's labeled, make sure we put the RTV silicone in the holes where the wires come out, check the battery, actually connect the battery, check the panel voltage to make sure it's getting up to the fuse holder, then put the fuse holder in. You cannot hook up the solar panel until after the battery is connected, very important. It might damage the charge converter. I put the Smart Farm name on the back. I make sure that the antenna is secure on the side of the case. I do a wire pull test to make sure all of the spade lug connections are on tight and the wires will not pull out. I check the battery voltage to make sure it's charged. I check the sensor voltages coming back from the sensors, as this is a live system now. Once I install the fuse, then the battery is being charged by the solar panel and the RF modulator is active and live, transmitting 1 watt. I just do an overall inspection for cracks in the case, make sure there's no debris in the rubber gasket area to make sure it seals good, and make sure all the nuts and bolts are tight, and that will do it.